itself. If you are going to do algebraic things with it, it doesn't work out. So we have to switch to what's considered a real number measurement in order to be able to use all of our algebra techniques. And that's where this idea of a radian measure comes in. When we're talking about the radian, okay, in general, it's a real number unit for an angle where the arc length and radius are equal. I'll let you write that down and then I'll talk about what it means. What it means is a radian is set up so that if the radius of your circle, so this is your radius, and this is your arc length. We use S for arc length. If the radius is equal to the arc length, then your angle is 1 radian. Okay, so 1 radian is the size of the angle required so that the radius and the arc length are equal. So, to find your theta for any side, you know, if I make this bigger, does the radius change if I make my angle bigger? No, but the arc length will grow, right? So to find the radian measure of the angle, you just do the arc length divided by the radius. So this is the formula that we are going to be using. When we do this, arc length and radius are both just a distance, and they're going to have the same unit. So if you do inches divided by inches, what happens to those inches? They cancel. And so most of the time when we're talking about radians, you don't have any units. You can write the word radian if you want to, but you don't have to. It's kind of a unitless thing. So from now on, if you write theta equals something, if you do not have a degree symbol, I am assuming it is radians. So you have to make sure, if you mean degrees, you have to put a degree. Anything without a unit is considered radians from now on. Okay, so let's just do a basic example here. If I told you a central angle, that just means it's coming out of the center of the circle, and a circle of radius 3 cuts off an arc length 6 centimeters. What is the radian measure of theta? I told you. Theta is your S divided by R. Arc length divided by radius. What's our arc length? 6 centimeters. What's our radius? 3 centimeters. So what's theta? Theta equals 2. And I don't have any unit there, so it's 2 radians. Now, we have 2 different types of measurement. And we're going to have to be able to go back and forth between the 2. So we have to think about how would you convert between degrees and radians. So that's the next piece to look at. Okay. So everybody have this one down? So, if I wanted in a circle, we know that I told you your radian measure is S divided by R. If you go all the way around the circle, So your arc length would be equal to the complete distance around the circle. What's that called? Total distance around the circle? Circumference. It's like perimeter, but in a circle we call it circumference. How do you find circumference?
Pi d.
Right, pi times the diameter. Or, so if we go all the way around, pi times diameter, which diameter is just 2 times the radius. So I'm going to say, if we go all the way around, my arc length is just my circumference, which is 2 pi r. What happens to my r's? They cancel. So in degrees, we know all the way around the circle is 360 degrees. In radians, all the way around the circle is 2 pi. So what that means is 2 pi is equal to 360 degrees. If you divide by 2, that means pi is equal to 180 degrees. So that is what we will use to convert between degrees and radians. Okay. Our pi is equal to 180 degrees. So most of this was me trying to justify why it is. But what you need to know, you need to know the theta equals S over R, and you have to know that pi is equal to 180 degrees. Those are the key things so far. So now we're going to start converting between the two. I want to change 45 degrees into radians. Okay, we've done conversions before. You know, we turn feet into inches or miles or things like that. And what we always did is multiply by a fraction. If my degrees are on top and I want to cancel it, it needs to go on the bottom. So what's the conversion between degrees and radians? What did you just write down and highlight? 180 degrees equals pi. So I'm going to put my pi on top and my 180 degrees on the bottom. Okay, the degrees cancel. If you type 45 pi over 180 in your calculator, you will get a decimal. Typically, we are going to leave things in terms of pi when we can. So what I want you to do is just type in 45 over 180. And let's just put that as a fraction in lowest terms. And we get pi over 4. So 45 degrees is equal to pi over 4 in radians. I want you guys to do one. Convert 450 degrees to radians. So again, we want to cancel the degrees, so you just multiply by pi over 180 degrees. Degrees cancel. 450 over 180 reduces to 5 over 2, so 5 pi over 2. You're welcome to write the word radians, but you don't have to. Let's say I gave you this one, negative 78.4 degrees. This one, my directions are to round to the nearest hundredth. So on this, I'm telling you, we're going to go ahead and multiply out the pi. So we have negative 78.4. Change it to radians, so multiply by pi over 180 degrees, so the degrees cancel. And I want you to type in everything this time. So negative 78.4 times pi divided by 180. Hundredth is how many decimal places? So rounding appropriately, it's negative 1.37. We get that? Let's go the opposite way. If I said to change pi over 6 in 2 degrees. So if we have pi over 6, what am I going to multiply by? 180 degrees divided by pi, because this time I'm canceling my radians, I want degrees. So what happens there? Pi cancels, you're left with 180 divided by 6, which is 30. Is that answer correct? Why? Come in. You have to put your degree symbol.
These tiers. Yeah.
Okay. I want you guys to do this one. What do you multiply by? Degrees over pi. So pi's cancel, and you get 140 degrees. Okay, so far so good on this? Let's say I gave you negative 4.5. If I say negative 4.5, is that degrees or radians? It's radians. Don't get in the habit of thinking that it has to have a pi to be in radians. If it doesn't have a degree symbol, that's radians. So this time I'm asking you to change this to degrees. So we are just going to multiply by 180 degrees over pi. The directions on this one said to round to the nearest tenth, so I'm telling you if you're rounding, go ahead and divide your pi out. So negative 4.5 times 180 divided by pi. What do you get to the nearest tenth?
Negative 257.8.
And that is degrees, so you have to have your degrees. Okay, so if you're just straight converting, you don't have to worry about having it positive. You don't have to add 360 or anything first. You're just straight converting using either 180 over pi or pi over 180, depending on the way. All right. Okay with everybody? What I want to do now is we are going to start talking about this unit. Is there something wrong with that?
No, I have to do that thing.
You need to watch the video.
Okay.
I am actually going to give you this handout. Notice at the top it says quiz. It's not a quiz, but I might give you the exact same thing as a quiz later on. Very subtle hints, guys. Okay, we're working on the bottom part right now. we're going to talk about this circle. So the very first thing we are going to put on this circle is our degree measures. And these are actually all the common degree measures that we've talked about. So if you think about our hand trick, we started with 0, and then we did 30, 45, 60, and 90. Make sure you're putting degree symbols in all this. Let's jump down here. What would this line represent? Okay. Then for your reference angles are distance to the x-axis. So this would have a reference angle of 30. So to find that, you'd have to do 180 minus 30. 180 minus 45. 180 minus 60. Is everybody understanding how I'm getting this? How would I get the angles in the third quadrant? Reference angles are from the x-axis, so we'll just do the 180 and we will add our reference angle. So 180 plus 30, 210. 180 plus 45, 225. 180 plus 60, 240. What would this line down here represent? 270. Okay. Fourth quadrant, what do we do?
Same thing from 0.
Correct. 0 is the same as 360. In general, if I give you this as a quiz, I don't care if you call it 0 or 360. So this time we subtract from 360. So 360 minus 30 is 330. 360 minus 45, 315. 360 minus 60 is 300. Are there any questions on how we got those angles? Now we are going to add radians to this. So if you're color coding things, I would switch colors for your radians. 0 degrees is the same as 0 radians. Okay, if I wanted 30, if you forgot, you could technically convert all of these things. We know how to convert. So if I have 30 degrees and I want to change it to radians, I do 30 times pi over 180. What does that give me? Pi over 6. 45, I think we did that one, didn't we, in our first example? 45 is pi over 4. If you want to change 60, you do 60 times pi over 180, and you get pi over 3. If I want 90, I do 90 times pi over 180. Pi over 2. Okay, let's just stop a second. In this first quadrant, what do you notice about all of these? Do they have anything in common? Means up pi over 6, pi over 4, pi over 3, pi over 2. Okay, it's all pi over a number. What's happening to those numbers, those denominators, as you go up? They're getting smaller. 6, 4, 3, 2. Okay. Let's jump over to our 180. 180 we already know is the same as pi. Okay. We have several ways for how to get these others. We could keep converting by our multiplication. I could do 150 times pi over 180 and get it, and that's going to work. We could do it like we did with our degrees. We did 180 minus 30, so I could do pi minus pi over 6, and that would work. So tell me, what does 150 turn into? Either convert it or do pi minus 5 or 6. What do you get?
5 or 6.
5 or 6. Okay. Take a second and compare. This denominator is 6. That denominator is 6. So these both have the same reference angle and they get the same denominators. How are 5 and 6 related? 5 is 1 less than 6. So if you just had to take a shot in the dark, what do you think 135 might turn into? 3 pi over 4. Let's test it. 135 times pi over 180. Does it work? Yeah. The denominator matches your reference angle, so it's over 4. The numerator is 1 less, so 3 pi over 4. So 120 should be 2 pi over 3. Okay. So our denominators match. In the second quadrant, the numerator is 1 less. Let's go to the third quadrant. At 210, any idea what you think the denominator might be? 6 probably, right? It's a reference angle of 30 again. Why don't you do 210 times pi over 180? What do we get? 7 pi over 6. Okay, so my denominators still match the reference angle. How is the numerator related? 1 more. So 225 should be 5 pi over 4. Because it's a reference angle of 45, so pi over 4, and the numerator's 1 more. Okay, 240, that's a reference angle of 60, so that would be 4 pi over 3. What do you think 270 will be? 3 pi over 2. Okay. Let's look at the 4. So 330, at the very least, we know it's going to be something pi over 6, right? So reference angle of 30. If you do 330 times pi over 180, what do we get? 11 pi over 6. What about 315 times pi over 180? What does that give us? 7 pi over 4. Do you see the pattern? What is it? Right. Times 2 minus 1. 6 times 2 is 12, minus 1 gave you 11. 4 times 2 is 8, minus 1 is 7. So this one should have a denominator of 3. So if you take that times 2 minus 1, it should be 5 pi over 3. Okay, that works because if you think, when we did the degrees, we did 360 minus. 360 is the same as 2 pi. So it's just 2 pi minus your reference angle. That's why it turns out to be double minus 2. Okay, so this is our unit circle. Eventually we are going to add ordered pairs on this, but not for a while. Right now we have all of our degree measurements and all of our radians. You can expect me to give you some quizzes like this. I've got a whole stack of circles because you have to be able to do this. Now, we know if you can get the degrees, you could find every single radian just by converting. But it's a lot easier if you recognize the patterns. We know in the numerator, in the first quadrant, the numerator was just pi. Second quadrant, it was 1 minus the bottom. Third quadrant, 1 more than the bottom. Fourth was double minus 1. And if you look, we have our reference angles that line up. You know, these lines are all the 30 degrees, so they're always over 6. The next line, those were the 45, so those are always over 4. And then you go to your 60s, so those are always over 3. So there's a lot of patterns going on here. Is there any questions? Next thing I want to do is fill out that table. We have done this table before, but what I've added is the radian column. So I want to see, without just copying it off the circle, can you tell me? 0 degrees is the same as 0 radians. 30 was pi over 6. 45, pi over 4. 60, 90, pi over 2. 180 is pi. What was 270? Three pi over 2. And 360 is the same as 2 pi. Okay, so the reason I put this table is I want you to recognize I don't have to say the sine of 30 degrees anymore. I might say, what's the sine of pi over 6? Because pi over 6 and 30 degrees are the same, the value is the same. So I can ask the question in terms of degrees or radians. So at 0, sine of 0 is 0. Cosine of 0 is 1. Tangent of 0 is 0. At 30 degrees, or I might say when theta is pi over 6, sine is 1/2. Cosine is radical 3 over 2. Tangent is, come in, radical 1 over radical 3, so radical 3 over 3. At 45, or I might say pi over 4, sine is radical 2 over 2. Cosine, radical 2 over 2. Tangent, radical 3 over 1, which is radical 3. So, yeah. I think I switched to 60 for some reason. Thank you. I did that on purpose, making sure you're paying attention. Okay. At 60, sine is radical 3 over 2. Cosine, 1/2. Tangent, radical 3 over 1, so radical 3. At 90, sine is radical 4 over 2, so 1. Cosine, 0. Tangent, undefined. At 180, or I might say, what's the sine of pi? So when we got to the 180s and 270s, we usually drew a picture. 180 is here, your x is -1, your y is 0, r is always 1. Sine was y over r, so that is 0. Cosine x over r. And tangent y over x. 0. Okay, if I asked you about 3 pi over 2, that's down here. So this point would be 0, -1. So sine y over r, -1. Cosine x over r, 0. Tangent y over x, undefined. And last one, 360. That's the same as 2 pi, which is the same as 0. So it's the same as that top row. here, all I want to do to finish off today is practice evaluating trig functions with radians instead of angles. So, like that last page on your test where I would say, what's the cosine of 45 degrees? Now I'm just going to say, what's the cosine of pi over 4? So I'm asking the same question, just in a different way. So if I wanted to know the sine of pi over 6, eventually we'll get to the point where we just see pi over 6 and we don't really necessarily have to convert it. But right now, if I see that, I'm thinking, okay, pi over 6 is the same as 30 degrees. And I know the sine of 30 is 1/2. Okay, I don't want you just copying it off that table that we filled out. Use the table to check yourself, but make sure you can figure these out on your own. Okay, 4 times the sine of 7 pi over 6. Okay, we have to write down the quadrants and reference angles, just like we did on the test. 7 pi over 6. In which quadrant was the numerator 1 more? Quadrant 3. Okay, and the first quadrant is always just a 1, second quadrant 1 less, third quadrant 1 more. Reference angles with these are really easy because remember, all of our reference angles, the denominators never change. So regardless of my numerator, I know my reference angle is just pi over 6. Which when I see that, I'm thinking 30 degrees. Okay, in quadrant 3, is sine positive or negative? Negative. What's the sine of pi over 6, or the sine of 30 degrees? 1/2. So I get -2. So the process is the same, just in a different unit. What do I need to do first on this one? Again, the pi over 6. Okay. I have to caution you, if you do try to use your calculator, don't put the pi in. It'll change it to a decimal, and I don't want that. If we do 2 times pi over 6, that would be pi over 3. So we really have pi over 3 plus pi. Now, if you were doing this in your calculator, you would do 1/3 plus 1. You don't put it in pies. So what's that turn into? 4 pi over 3. Now I want quadrants and reference angles. What quadrant is 4 pi over 3 in? Third again, because it's 1 more. Reference angle is just the pi over 3. Your denominators stay. So in the third quadrant, sine is positive or negative? Negative. And the sine of pi over 3. When I see pi over 3, I'm thinking what? 60 degrees. So what's the sine of 60? Pi over 3 over 6. And that would simplify into -2 radical 3. Questions? What we really need in this section is just time for you guys to work and practice seeing the radians and get familiar with them. So I have a homework assignment. It is not due tomorrow. Tomorrow's Friday, so I guess it won't be due until Monday. You will have a large portion of class tomorrow to work on it. I'm not going to guarantee a full class period, but you will have quite a bit of time tomorrow to work, and you have a few minutes to start now as well.